Have you ever noticed that when you pick up a deck of playing cards, you never throw all of the cards onto the table and start over? No? You pick up one card, then another. Each new card quietly slides into the exactly right place. You don't think about it. You just do it. And here's what exactly fascinating. Your brain has been running one of the most elegant algorithms in computer science since you were a child. And it's called insertion sort. Most people think algorithms are invented inside laboratories by brilliant programmers, surrounded by giant computers. But some algorithms were not invented. They were discovered because humans were already doing them naturally. Every time you sort your cards, every time you arrange books on a shelf, every time you insert a contact into an alphabetical diary, you're unknowingly performing insertion sort. Today, we are going to discover why. Imagine you are the librarian of an ancient library. Thousands of books around you. Every shelf is perfectly organized from A to Z. Then a delivery arrives. Just one book that's new. Now think carefully. Would you remove every single book from every shelf and arrange everything again? Of course not. That would take forever. Instead, you simply ask one question. Where does this new book belong? Once you find the answer, you gently slide the nearby books to a little to the side, place the new book, and the library is perfectly organized again. That's not just common sense. That's insertion sort. Now replace books with numbers. Suppose we already have 2, 5, 8, and 11. Everything is already sorted in ascending order. Suddenly, a new number arrives. Where is 6? Where should it go? Between 5 and 8? Simple. So what happens? Does the computer rebuild everything? No. 8 moves one step, 11 moves one step, 6 quietly slips into the empty space and done. Nothing else changes. The computer didn't sort everything, it simply inserted one newcomer into an already organized world. And that's where the name comes from. Insertion sort. Now here's the beautiful part. Insertion sort doesn't begin with a perfectly sorted list, it creates one very slowly. Imagine 5 students standing randomly. 8, 3, 5, 1, 6. Instead of panicking, the algorithm simply says, I trust the first student. A single student is already sorted well, quite intuitive and straightforward. One person can never be out of order, so the sorted world begins with just one element, not two, not five, just one. And this tiny observation changes everything. Now look at the second number, 3. Ask one question. Does it belong before 8? Yes. So move 8 and insert 3. Now two numbers are perfectly sorted. Next comes 5. Compare it with 3. Stop. Insert the 5. The three numbers are sorted. And notice something incredible.
Close your
The
eyes
sorted
for
part
a
keeps growing,
second.
one element
Your
at a time.
shorts
Like
are
building a city,
arranged
one
by
house after another.
color.
You'd never destroy the
Those
city. You
different
simply expand it.
colors of shoes. A
Close your
blue
eyes for a second.
shirt,
Imagine your
black
wardrobe. Your
shirt.
shirts are arranged by
Today you
color.
buy a new
Clothes,
black
different colors of
shirt.
shirts,
You
branded.
find the black
Move it forward.
shorts,
Two more. More
move
shirts are there.
one or two
Blue shirt,
aside,
black. Shirt,
and
white shirt, gray
insert
shirt.
the new
Today, you
one.
buy a new black shirt. Think of a Adidas t-shirt, right? So do you throw every shirt onto the floor and organize them again? No. You open the wardrobe, find the black shirts, move one or two aside, and insert the new one. For your wardrobe to be seem more organized to you, and then close the wardrobe. Finished. And that's insertion sort. Computers learned this from the way humans naturally maintain order, not the other way around. So now, you know what insertion sort is. You know why it exists, and you even know why it feels so natural. But one mystery still remains. How does a computer know exactly where to insert the new number? Does it look from the front, from the back? Does it remember? Does it guess? The answer is surprisingly elegant. And once you see it, you'll never forget how insertion sort actually works. Let's pick up the computer. Not a genius, not a magician, just patient. Imagine these numbers lying in front of us 83516. Remember, the computer already believes the first number is sorted. Why? Because one thing alone can never be out of order. So our sorted world starts here 8 and the bar in between, and at the other end 3, 5, 1, and 6. That vertical line is like a border between two worlds. On the left, everything is organized, and on the right, everything is still waiting. Now, the computer picks up the next number, that is 3. It doesn't compare 3 with every number, only looks backward, one step at a time. Is 8 bigger than me? Yes. So 8 moves one position to the right. Now there's an empty space. 3 slides in. And just like parking a car into an empty parking spot, the array becomes 3, 8, bar, 5, 1, 6. Notice something. The computer never swapped 8 and 3. It shifted 8. That difference is everything. Think about a bookshelf. If a new book belongs in the middle, you don't pick up every book and exchange places. You gently slide the nearby books, then place the new one. Books never lose their order. Insertion sort thinks exactly like that. It doesn't create chaos, it creates space, then fills it. That one idea makes the algorithm incredibly elegant. Let's continue our problem. Now comes 5. Current array 3, 8, bar 5, 1, 6. You ask one question. Is 8 bigger than 5? Yes. So move 8. Now compare with 3. Is 3 bigger than 5? No. Stop. And insert 5. Now the sorted bar grows again. 3, 5, 8, bar, 1, 6. Did you notice the rule? The computer never keeps comparing once it finds the correct position. It stops immediately. That's why insertion sort is surprisingly efficient when things are already almost sorted. Many beginners imagine the computer saying, let me sort everything. Is that what every beginner imagine? That computer will do everything for me. It never does. Instead, it says, I already trust everything behind me. I only need to place this one new comma. That single change in thinking is what separates beginners from people who truly understand algorithms. Algorithms aren't about doing more work, they're about avoiding the unnecessary scramble and work. Imagine your shoe rack, not a messy one, proper one. Your favorite sneakers on one side, formal shoes in another row, running shoes lined up neatly, and every pair placed where it belongs. Suppose you buy one new pair, maybe a new pair for the party, right? Maybe a fresh white sneaker, or a stylish black sneaker that fits between two colors already on the shelf. You
Running
do not take the whole
shoes
rack
lined
apart.
up
You do not throw
neatly.
every shoe on the floor and
Suppose
erase
you buy
everything from the year
one new
before.
pair.
You just look
To
at the
fit
shelf and ask,
between two
where
colors,
does this
you do
new
not
pair
take the
belong?
rack
That is
apart,
insertion sort.
one step
The sorted
over
part is a
and the
new shoe rack.
next.
The new shoe with the new cover.
Insertion
Your
short
job is simple.
feels
Make
natural.
space, then place it correctly. If a pair on the right is on the way, you slide it one step over, then the next one, then the next, until the perfect spot opens up. The new shoe slips in smoothly. That is why insertion sort feels so natural. Because this is how people already organize your life. A shoe lover knows this instinctively. You do not ruin the whole shelf for one new pair. Of course, you don't want to ruin your sneakers for one new comma. You protect the order you already built. You just insert the new one into the right place. Here is the catch. If your shoes are already almost arranged, this is fast, very fast. If the shelf is totally reversed and every pair has to be moved again and again, then the work becomes heavier. So insertion sort is beautiful because it is smart in the human way. It respects what is already sorted. It only fixes what is new. It only moves what is necessary. So remember this picture for a clean shoe rack, one new pair arriving, nearby shoes sliding aside, one perfect space opening up, and the new pair settling in without disturbing the whole shelf. That is insertion sort. Not loud, not flashy, just elegant order, one insertion at a time. And that is why, even today, it still feels like one of the most human algorithms ever made.